Negative exponents. When we're dealing with negative exponents, we have situations where the top number in a division problem ends up being larger than the bottom number. For instance, if we have x to the third power divided by x to the fifth power, we would then take x to the 3 minus 5 power, which would give us x to the negative second power. If we place that over 1, because any number or variable that we are given, if it does not have a denominator, can always be placed over 1 because it does not change its value. Because when we do that, to get rid of the negative exponent, what we do is we flip what is given to us. So it becomes now 1 over x to the second power. Now looking at another example, for instance, if we have 2 to the negative third power, we end up with 1 over 2 to the third power. Or we can work that out and it becomes 1 over 2 times 2 times 2, which is 1 over 8. Now if we have another example of 1 over 4 to the second power and we want to reverse that process and figure out what the exponent of it would be as just a power, then we would turn that into 4 to the negative second power. Now, if you notice, the negative power has nothing to do with the value of the number 4. So the base doesn't change values just because it has a negative exponent. Now, if we are given a number such as 1 over 25, we would have to put that as an exponent in order to change that to a negative exponent. So what times itself gives you 25? And we find out that that is 5. So we end up with 1 over 5 to the second power, which when we turn that back into a negative exponent becomes 5 to the negative second power. Now here's some harder examples. Now with this example, we have 4a to the negative fifth power, and it says if a equals negative 2, and it wants us to evaluate this problem. Now we need to remember that evaluate means to find the value, so we are going to end up solving this. So we plug in negative 2 for the a, and we end up with 4 times negative 2 to the negative fifth power. Notice how I put parentheses around the negative 2. And the reason why is because the a was to the negative fifth power. Therefore, the entire piece, negative and 2, needs to go to the negative fifth power. Now, when we try to solve this, we want to get rid of that negative exponent. So we're going to put what is taken to the negative exponent on the bottom, because it is on the top, and it becomes 4 over parenthesis, negative 2, close parenthesis, to the fifth power. Notice how the negative exponent went away, but the negative 2 stays negative, because the negative exponent does not have anything to do with the value of the base itself. Now, if we were writing this out to figure out the value, we would say 4 over negative 2 times itself 5 times, which we would end up getting 4 over negative 32. However, we have to simplify at this point, and both of those numbers are divisible by 4. So we would divide both by 4, and we would end up with 1 over negative 8. Now remember, the negative can go outside of the entire problem, or it can go with either the negative 8, or it can go with and make it negative 1. But we would only have one negative in the entire problem. Another example, if we have 3m to the negative fourth power, and it tells us if m equals 3, we are trying to evaluate this. Now, again, we would put in parentheses the 3, simply because we want to identify that that's what's being taken to the power. So it becomes 3 parenthesis, 3 parenthesis, negative 4 power equals 3 over 3 to the fourth power, because we are taking that negative exponent and moving it down to make it a positive exponent. Again, it didn't change the value of the 3, it just changed the value of the exponent. So then we would solve that. So we would take 3 on top times its, on the bottom, 3 times itself 4 times. And we would notice that the 3 on top would cancel out with one of the 3's on bottom, leaving us with just 1 on the top. and 3 3s left on the bottom. And 3 times 3 times 3 is 27, so our answer becomes 1 over 27.